Hey everybody, Brett Little from Green Home Institute here. Thanks for joining us all. We're going to go ahead and get started with the tour of the LEED multifamily building here pretty soon. So stay tuned.
Thanks for coming out today. Nice warm day for the winter solstice and a good day for touring a multifamily building under construction. So this project's called Maple Place. It's a 5-story, it's actually 4 residential stories over 1 garage. And got a few interesting things going on that we'll talk about today. I'm going to let Paul from JCS Construction, he's the builder, give a little bit of an overview of the project and the goals, and then we'll take a look at some of the exterior envelope measures.
Hi, good afternoon, happy holidays. My name is Paul Zimmerman. My partner Jonathan Shack and I are the developer and the builder on this project. It is a 5-story, 11-unit luxury condominium development, which obviously you know from Jason that will be LEED registered. We are shooting for a silver designation. Right now we have 8 of the units under contract. There are 3 more left to sell. The square footages are approximately 1,800 to 2,200 square feet. All 3 bedroom, 2+ bath. Each unit comes with 2 heated garage spots. We also have 4 private 2-car garages, which we'll show you in a minute, that are an upgrade. We are finding that what we anticipated as being the demographic of our buyers would be downsizers that live in the neighborhood already, and that is exactly what we're finding. Our buyers are anywhere from late 50s to early 70s, have lived in the neighborhood almost all their lives, want to stay here but want to be on single floor living. So that is exactly what we thought they were going to be, and that is what they are. Actually, if we want to walk down the sidewalk a little bit, you can see the back of the building and you can see a little bit of the insulation envelope that we are doing.
Hey everybody, thanks for joining us here. This is Brett Little, Green Home Institute. We're just taking a look at the exterior of this multifamily LEED building under construction as we speak here in Oak Park, Illinois. This is a 4-story multifamily building. Is it mixed use at all?
It's a 5-story.
5-story. Oh, yeah.
No mixed use.
All right. All residential.
All residential. Parking on the first floor. There is a storage in the basement on the front of the building, and then residential on the top 4 floors. It's 3 units per floor, and the penthouses, there's 2. They have extended terraces on the penthouses, and there is also going to be a green roof surrounding the terraces on the top floor.
Back a little bit. The top of the 4th floor would be vegetated green.
So you can see here the Blueskin, the Henry Blueskin, underneath 1.5 inches of insulation on the outside of the building. The insulation envelope is obviously going to be very tight, much tighter than you would find in most developments. And because of that, and Jason will be talking about that later, each unit has its own fresh air exchanger. So there's going to be fresh air brought into the building, heated in the winter, cooled in the summer, to make up for the fact that the envelope is so very tight.
Pipes are going to...
Right. Right. Exactly.
So the Blueskin replaces your traditional house wrap or Tyvek. And David will talk a little bit more about that inside. But then we wrap it with the sweater, with the 1.5 inch continuous insulation. That really helps reduce the thermal bridging across the envelope and makes it a really efficient warm wall. And that's going to have an impact when we get inside and start to look at mechanicals on how we did the sizing for the mechanical system.
The windows are aluminum.
The windows are wood aluminum clad windows, double paned. I forget the U value. It was pretty impressive.
Yeah, it's classic
0.29.
They're out of Libertyville, I think.
Yeah.
Up that way.
Relatively locally manufactured.
Yes, absolutely.
Great performance. It has a 0.29 U value and 0.18 solar heat gain coefficient.
0.18.
Lindsay, the Green Raiders said 0.29,
0.29.
and all right,
0.18.
U value and 0.18 solar heat gain. All right, for the windows.
So now that we've all seen this, let's go inside. It's a little bit warmer, certainly quieter. So we're going to go up to the second floor, through the garage, in the middle of the building. There's a stairwell, and we'll take it up to the second floor.
Hey everybody, thanks for joining us here. We're going live for the next 45 minutes or so for our free CE tour. My name's Brett Little here, Executive Director at the Green Home Institute. Green Home Institute is a nonprofit with a mission to empower people to make healthier and more sustainable choices in the renovation and construction of the places we live. So we're very excited to be here in Oak Park, Illinois, where we're headed into this multifamily housing building that's under construction as we speak, this LEED registered building pending silver. So thank you for joining us, and if you have questions, feel free to send them over. We've got a live tour here today, but feel free to send your questions and we'll try to get them answered for you. So thank you. And here's just a shot of the group joining us today. Pretty large group, bearing the not so freezing cold here.
70% or whatever comes back on that price. Yes. Yes, actually, so.
Hey everybody, we're back again. We had a weak connection there down in the building for a second.
Everybody filter into the living room here.
See that they have 6-inch stud walls there.
All right, so I think most people are here at this point. So this is one of the units on the second floor above the garage, which is conditioned at 55 degrees. So a little bit of an interesting scenario. The framing's mostly open web trusses, as you can see. And even with that, the Jonathan, Paul's partner, where are you, Paul?
I'm right here.
He was concerned about being able to get all the mechanical, electrical, plumbing into the space. So we'll come back to that in a little bit. But in terms of the envelope, you can see bringing in here, wrapping around the windows, this Blueskin component. And David, you want to give a quick overview of this weather barrier?
Yeah, absolutely. So the dark blue that you see on the outside of the building kind of coming into the window jambs here is a self-adhered air and water barrier. So it's also very efficient because it's a vapor permeable. So if you think about putting a Gore-Tex jacket on, that's literally what we're doing to the building. So you're protecting the exterior of the building from air and water, but you know, as humans, we create a lot of you know, moisture vapor inside the envelope, so it's actually able to escape out. And the nice thing about it is that I didn't realize how hot my truck has been lately because the water vapor is actually escaping out of this pretty quickly, but there's water in this little jar right here, and it's also nail sealable. So Jason brought this up a couple weeks ago. If it's doing this to water, it's also doing this to air. So it really is a top to bottom air and water tight building envelope, and you know, and then you'll have that continuous drainage plane on the exterior of the building as well. So, and Jason, correct me if I'm wrong, bat insulation that's going on in the interior of the wall. So we like to kind of look at it as a complete wall system with the air penetration being pretty much completely eliminated. You're able to go back to more economic practices with bat installations instead of using, let's say, like a spray and foam option. So
All right, so it's a fiberglass bat will be the insulation. Obviously, you can see our breath, so it's not in here yet. But we are relatively enclosed with all the windows mostly in place and the weather barrier on top of it. And the air sealing properties that this does works really well. And Benjamin Van Horn with Greenline uses this on single-family homes that we've tested, and they're meeting basically they're meeting passive house air infiltration rates with this WRB product. So pretty impressive performance. And that allows us to, when coupled with the 1.5-inch continuous foam board wrapping the building, has a pretty big impact on the mechanical system design. So
Go ahead.
So here we are on the exterior of the 5th floor. It's a great chance to see the different layers of the wall assembly. So one of the key components to this assembly is the Blueskin wrap. It's a watertight, airtight house wrap that basically seals to any penetration. So any nails that are going in here, the wrap like seals around it. So it helps it become airtight and watertight to ensure that it's protecting the rest of the assembly from that. So we've got that on the underlayer, and then we've got continuous exterior foam board. This is an R7.5. So this is throughout the entire exterior envelope. This is helping with the thermal transfer. On the interior, we've got 2x6 framing with an R15 mat. This helps with the heat transfer. So in the spots where we've got the studs, this is going to give it that extra thermal protection or layer. It's kind of like a jacket surrounding the whole building, basically. So that's what we're seeing here. We've got our flashing around the windows to make sure that the water stays out, the water and air stay out. That's what covers it.
Great. Thanks,
Yep.
Lindsay from EcoAchievers, who is the lead green rater on this project. So she'll be making sure everything is done right as the project goes on and doing the final testing and inspection.
Yep, so next step, just going to take another walkthrough. Next step is the insulation inspection. So make sure that that's at grade 1 and everything is done the way it's supposed to be. So,
Thanks. Yeah, and here's a beautiful shot of Oak Park. Woo, it's cold.
It's going to help reduce that utility load, and then it's going to increase comfort within the building.
And Tim, if we didn't have that envelope, what size would these furnaces have to be?
Well, traditionally they usually put in 80,000 to 100,000 BTU furnace, and that's because a lot of the buildings aren't properly air sealed, and you get a great stack effect in the building.
Is the ductwork the same velocity as the regular residential system to air complex?
it's not a high velocity ductwork system.
It's actually a variable velocity, meaning that the system will just match the heat load that you need for your building. So eventually it could be considered high velocity, like if it was like last week, -11 out,
Right.
it would run at a higher velocity for that period of time. But for the most part, because you match out, these are what, 25 CFM, 30 CFM per register coming out of the building.
And it's coupled with a 27 SEER heat pump. It basically looks like the same type of condenser you see for a mini split air source heat pump. And so that's what it's using for the cooling side, and there'll be, so it's a horizontal discharge. There'll be one per unit on top of the roof of the building, as well as one for the common area.
So what velocity are you running when you're running your air conditioning?
I think it's around 400 CFM. We've actually got spec sheets on the equipment on that insulation foam board if you're interested in mechanicals.
400 CFM, would you be hearing it noticeably?
So that was a good question. Jeff asked if you'd be hearing it, and
I think we could let Paul answer.
Yeah, I was going to say, this is the first installation in Illinois of this type of system. So to basically help make this happen, Paul and Tim and Jonathan on the development team actually took a trip up to Canada to see this installed in a few places. So,
Yes.
Paul, what were some of the concerns you had, and what were
Well,
the
absolutely.
findings?
You know, I wanted to see, number one, what it felt like in the units, what it sounded like in the units, and I mean, you can barely tell it's on. I mean, you know, you have to go up and put your hand up to it to even, you know, feel any kind of blowing. I didn't feel it at all, and so, you know, I love the fact that, number one, I can tell my buyers that they're not going to have the same kind of variations in temperature that they are in a regular building where, you know, you have a 90,000, say, BTU building kicking on once the temperature gets to a certain level. You have a more constant temperature, and then also you don't feel that big blow when the unit kicks on.
I think one thing you'll have to bring up too, because people are used to their units ramping up and down, and they're going to see it running all the time, and they're going to be freaking out, like,
Right.
it's using all this energy. So I assume that'll be an education piece to that.
Yeah,
I've
absolutely.
had so many people tell me that when they upgrade to newer furnaces. So
And the other thing, actually, we had a buyer this week ask about a humidifier. You know, does their unit need a humidifier? So, you know, obviously not only because of the Blueskin, but because of the fresh air exchangers, you don't have that same kind of humidity problem that you do with them.
Let me actually get into it. We haven't talked about that.
Oh, okay, good.
So every unit inside every residential unit, a condo in this building will have its own balanced ventilation system. So we'll be bringing fresh air in, exhausting stale air out. And it basically transfers through a little core like this. We'll be using Renew Air products on this one. So this is a nice little sample they gave us. But basically the air streams pass over each other in a way that allows that outgoing heat that you paid to condition the building to 72 degrees or whatever to preheat the air that's coming in at today, you know, 25 degrees. And so that 25-degree air gets brought up to temp a little bit closer to around 55, 60 degrees, and the outgoing air obviously gets cooled down, transferring the heat into the incoming airstream. And so you get some energy savings recovery, but what's nice about that too, even more so, especially for buyers in a luxury condo like this, is it delivers clean air, and in a balanced ventilation approach, distributing the air through the same ductwork, and then what's a little bit unique is that the ERV is acting as a central exhaust for the building as well, so it's actually picking up from the bathroom and laundry areas in the project to be able to remove the stale air and moisture out, and some of that moisture will actually get transferred through the outgoing air into the incoming air to help humidify the air in wintertime. Just basically reaching an equilibrium point with that. Each individual unit has its own ERV. It'll be the mechanical closet next to the furnace. So you can see that they roughed in the ductwork, the insulated ductwork on the outside, and actually intake and exhaust lines for that'll be feeding into that mechanical closet.
Does the ERV have any of its own ductwork?
It's basically ducted on the exhaust side. So it's not ducted on the supply side to each room. In some of the projects we work with that are really going for high performance, we see that. Decoupling the heating and cooling air from the ventilation air, that's very typical on, let's say, a passive house type of project. But in this project, we are mixing it, and it is still pretty low velocity, as Tim explained, so we think it'll perform pretty well in that respect.
Yeah, the other part is because the furnace runs all the time, it will sister up very well with the energy recovery ventilator.
One of the things that's unique about this building too is that, you know, they obviously have a lot of, you know, it's a luxury condo building. There's very large kitchens, I think, right around here.
Yeah, actually on that
on this wall. And so there is going to be direct exhaust out. That's a requirement for a LEED project for the kitchen hood. The other side of that, though, is because this is, you know, a higher end space, they're actually putting in pretty high end appliances in range hoods. And we run into an issue when we see range hoods that are over 400 CFM being able to have adequate makeup air, so we're not backdrafting any other appliances or gurgling water out of the toilets or sucking up cats, right? So in this project, the other thing they're doing is they have a separate makeup air unit with a motorized damper that will open whenever somebody turns on the kitchen range hood to make sure that there's that balance of airflow and pressure in the space. And by doing all of this, Paul and Jonathan realized some pretty significant savings when we basically realized that if we did this for every unit, and we're also doing it in the common areas too, picking up exhaust through an ERV for all the toilet rooms, and then putting that into a heating and cooling system just for the lobbies. It pretty much eliminated completely a lot of costs from having a large makeup air unit on top of the building. And so the extra steel, structural steel that was going to be required, extra costs for craning in a big makeup air unit, extra costs for running that system on an 80% efficient system on a pretty continual basis to make up for the fact that there might be every fan running in the building, ended up being a lot of both first cost savings and it'll be long-term cost savings for the owners of these units.
So the sizing of your makeup air is driven by the offset of the kitchen exhaust, the hood exhaust?
If we didn't have the kitchen hood, if it was lower than 400 CFM, we could have gotten rid of that separate makeup air coming in. I mean, it's really just a relief makeup air for that, but it's not a makeup air unit.
Individually ducted into each face.
Into
with a
each,
motor on
yeah,
the
that's
back?
going into the furnace room as well.
The makeup area is
Like
Yeah.
analog?
for the kitchen hood,
Yeah,
and that's motorized with the kitchen hood, so the after
Right.
opens when the hood's on, brings it
Right.
into your furnace.
yes, it'll be a low voltage wire connecting it from the motorized damper to the power of the kitchen hood.
And so then even more so in a luxury condominium building, you're not gonna smell what your neighbor's cooking. Like that's going right out.
That's a good point, and I'm going to turn it over to Lindsay. Lindsay over here, we do a lot of work in multifamily buildings, and smells and odors and air transfer between units is something that we do a lot of testing on.
So in addition to all of the pre-work with mechanical design, we also did an energy model on all of the units, which incorporates how all of the unit systems are working together to project the actual efficiency of the unit. So there's the component of designing it and incorporating all of that, but then we'll also go through on each unit and do an insulation inspection as well as a final site visit. So it's very important that we are confirming the actual energy usage of the unit and how the unit is acting in its final state and not just a projected model. As many things in our own lives maybe change from plans, that happens on the construction site as well. So we need to confirm that what we have assumed is what's actually here. So one of the elements that couple with the continuous insulation and the Blueskin is the blower door test, which is very similar to this. So we'll throw this in an exterior. I'll probably put it in this door when I'm doing the testing. And we depressurize the unit and we get what our final infiltration value is. And it's a compartmentalization test is what it's called. And that comes into play when you're talking about hearing or smelling your neighbor's cooking, whatever other orders might be happening, you know. But it's really trying to ensure that this unit is separate from the other unit, from upstairs and downstairs.
So really, that's not necessarily an energy efficiency thing, but a environmental quality on the compartmentalization, right?
Yeah,
Just
I mean it's both,
health, comfort.
because the infiltration has such a huge impact on, as we heard from Tim, the mechanical design and how that's selected, to comfort, to just a large range of items. So we'll do a blower door test. We'll also do duct test and a ventilation test to make sure that all of the systems are running how they're supposed to. And that gets QA'd and is part of the LEED process and as part of the HERS rating that happens. So it's a great way to have that assurance and that quality assurance that you're having a third party come in to do this test to make sure that the building is performing as it's supposed to.
Any air sealing measures between units?
Yes. We've done blocking in between units, as well as we'll caulk. We're paying a lot of attention to the caulking of joints, and having the framing stop, but blocking go all the way up to separate them from additional units.
One of the things we find on a lot of multifamily units is that attention between units doesn't get nearly as much attention as the exterior wall. And so in this unit, not this wall right here, that's a kitchen wall, but the one behind it is actually a demising wall. You can kind of tell the studs look a lot closer. It's actually a staggered stud wall, and they'll be wrapping some fibrous insulation in between there to help with sound deadening and everything. But that doesn't really stop the airflow between units. So one of the things that they'll be doing, well, they're doing a pretty comprehensive built-up wall or floor assembly to help, which will end up doing a lot of sealing at the bottom plates of this unit. And additionally, there'll be, like when we have, like you can see there's an electric outlet in that separating wall there. They'll actually be making sure those are sealed on the back side of the box. All those little holes will be covered because those will all leak through the outlets. And also making sure that all of the mud rings are all caulked, making sure top plates are caulked to make sure that this unit really is as separated as possible from the adjacent unit. Because as Lindsay said, you know, the red door of truth shows. When we're running the blower door, it doesn't care where the leakage is coming from. On this unit, you know, 50% of the wall is exterior, but 50% is interior to another unit. So we got to take the same care on all sides.
Yeah, in addition, it also is a safety issue because it's also a fire hazard. If you have an air pathway between a unit and another unit, fire can easily spread across there. And it always should have been taken care of, but without blower doors, you only were able to do a visual inspection of it, whereas now we can actually see those numbers. And we can make sure that the units are fully isolated from the other unit.
So I think that's all we have for the formal tour. What kind of questions do you guys have about any of the mechanical, envelope, etc. questions?
Yeah, I was thinking the demographic you have in mind, people with single-family homes, older people, maybe concerned about any kind of environmental noise outside their living space. So you've addressed that, sounds like. And would include outside noise as well as above and next door. I mean, if I would buy this place, I would not want to be annoyed by outside noises.
Yeah, the continuous foam exterior actually does a good job of stopping outside noises, so the traffic, street noise from Chicago, and really half block over is Harlem Avenue, pretty major road with lots of trucks. Interior units, it really is, that air sealing ends up stopping a lot of sound waves and sound transmission.
Are you doing something above here too?
Yeah, they'll be doing a full cavity insulation up there. It's a fibrous, and then on the floors, they're doing an insulation layer. That's why we're walking on wood. Between the wood, and then there'll be another concrete floor, and then they're gonna any gypcrete on top of that, and then something else. It's a very
And then a sound attenuation pad, and then the floor. So yeah, you shouldn't really, unless they are bouncing a big old basketball, I don't think you're going to hear much of anything from upstairs.
Yeah. For those of you that are interested in mechanicals, there are some info sheets on the foam board over here, and there's an actual unit. It's a 15,000 BTU unit, so it modulates from 6 to 15. And that one, it actually will be the one that we'll be using in the common area space, but it is, it can also be used in this particular unit as well. So, other questions, comments, concerns?
Have you guys ran one of these systems yet? One of these HVAC systems?
We have not run one here. Like I said, Paul, when we saw them operational somewhere else, I don't think you have gas to the building yet, right?
We have the gas hookup, but we don't have the meters in yet. Gotta love Nicor.
When do you use caulking take place?
When does what?
Caulking take place.
Caulking. Well,
Air sealing.
yeah, it's, a lot of times the people that are doing insulation are doing fire caulking, so it'll be around that time. Before drywall.
That's the first blower test?
Well, we probably can't do a blower door test because they're not doing like gyp board or sheathing first. Sometimes we like to do it at mid-construction. It's difficult on a multifamily unit to be able to do that unless everything's pre-rocked at least. Sometimes if we're doing a fast house or something, we'll ask to be able to do that to make sure that the assembly is performing well.
Did you need heat to do the caulking?
It depends on the material. Some of it like
Will be heated soon.
they still got some a fair amount of electrical I think still to be worked through as well. So
Will be heated, I hope, second week in January.
Do you have the building code issues?
No. Not that I know of.
Do you want to talk about
do you know any, Paul?
Not that I know of.
Another question on HVAC, are you doing pressure balancing with the rooms? Or are you relying on undercuts of doors?
Because it's a low amount of volume coming into the room, but there is no, I don't know if you saw it, but there is one centralized return. There's not a return ducted to each room, so we're not anticipating having to do that. But actually, as part of LEED, we will be doing pressure balancing to make sure that there's not more than a 5 Pascal difference between the hallway and a closed door. And if so, then they'll probably undercut the door. I don't think we need to, we're gonna be at the point of having to do transfer drills or anything like that. We run into that with actually a lot of our Energy Star projects and affordable housing end up, the systems that are being put in are so powerful that they end up way over pressurizing the space, and that ends up being an issue where people do have to go back and add transfers or jumpers or something like that. We don't anticipate that here though.
You talked a little bit about maybe adding or pre-wiring for solar. Can you talk a little bit briefly about that and why
Right.
why not you might not do that or why you may?
Yeah, that is absolutely something that we are considering is to pre-wire for solar voltaic on the roof, because obviously this is a great location for it. And then the other thing that we have had interest in from at least one buyer is a car charger in the garage. So that's another thing that we are looking at. I think it's coming. It's coming for all of us. And as a developer, I just have to let you know that this unit is available. 2,000 square feet with a 38 by 8 terrace on the back, 3 bedrooms, 2 full baths.
And 2 garages.
And 2 garage fronts.
Huge garage.
Any other questions? Yes.
What's the square footage of the green roof compared, like percentage-wise, to the rest?
Percentage-wise, it's probably about 30%.
Yeah, the green roof surrounds the terraces on the penthouses. So it's not the full roof, but yeah, it's probably about 30% of the total.
It's a good question because in LEED for homes, there actually is credit for getting a green roof, but you have to be 50% or more of the rooftop area. Although the project's doing it, they're not necessarily getting any LEED points for it. They're doing it for other reasons. And it's actually going to be a nice amenity for those top floor.
Right. They can't walk on it, but they can enjoy the beauty.
Right.
There was a connection with stormwater mitigation, but that isn't enough for the LEED.
Yeah, we're still
aspect.
tying into downspouts.
Okay.
Do you want to thank everyone for coming out on a cold day? Eco Achievers, who Lindsay and Tim and I and someone else that's not here work for. We actually are hosting.
Do us again briefly about the HVAC with the smaller size furnaces.
The whole overview of them.
Yeah, just a real the 2-minute spiel that Tim gave. So
yeah, I mean basically because the envelope's superior than most, the loads end up being decreased a lot, and we have pretty good overhangs actually on our south windows and a lot of the units due to the balconies. And what we saw was that the loads were really low, and we could get away with most conventional equipment was too big. And so in this project, they're actually putting in, you can see the ducts up here, very small ductwork that's 2.5 inches in diameter. That's pushing through at a relatively low volume to be able to condition the space.
Oh wow!
And that is that provides enough heat and cooling on a more continual modulating basis, so it's not a single stage or even a dual stage furnace. It's a modulating furnace with a variable speed fan, and then a heat pump condensing unit in order to provide a SEER 27 efficiency on the cooling side. So It really is, they call it the right size system in order to make sure that when you get loads this low, the smallest furnace they have actually goes between 6,000 and 15,000 BTUs of heating and cooling. And
Usually they're like 20, right?
Yeah, usually
25 at the lowest.
Even that's low. I think 40 is the lowest I typically see.
Okay.
45 maybe. And they've got, their cooling units are like 3/4 ton they go down to. So it really is paying for what you need and getting the most comfort and efficiency out of it.
Great. Well, thanks, Jason, for taking us through this. Jason
thanks
from
for joining.
Eco Achievers, one of our longtime education partners and Green Raiders out of Oak Park. If everyone wants to stick around a little bit, I can take you through some more of the building. And I think there's some documents too. Yeah, so
Let me turn this over because this actually has the pieces of the ductwork system together.
yeah, and that's there's just some details right there. This is the specific system that they'll be using. It's a Canadian system. I know there are other low ones, low modulating systems as far as furnaces go that you can check out now that are coming out of the market. I think there's one in Colorado. So again, you can just take a look at some more of the building here. Some of the staggered stud approach that they use here. There's the outlet box he was talking more about as far as insulation goes. Some of the window detailing here. And let's see if we can find one of those systems.
Where are you going?
Enemies? Here we go. So here's one of the, I believe this is for the common area, but this is, you can see how small this this furnace is in comparison to, how big usual furnaces.
Come through here.
So you can see them there.
That's the exhaust there, and then that'll go to the ERV and go out. Okay. The lobby's got its own ERV that's picking up an exhaust.
And again, we're just taking a little more tour of the building, but again, it's pretty preliminarily as far as the construction goes. And we'll be uploading some photos of the final construction image as well as tracking this project through its construction stage. Other aspects of LEED include location and linkages, or as it'll be renamed, location and transportation. So this building, if you Google where it's at in the middle of Oak Park, Illinois, has great connectivity. It maxes out a majority of its location and linkage points as far as walkability, community resources, diversity of resources in the area. It's going to have a great density of units to square footage. So that means, fitting more people, but again, in a relatively good amount of space and building upwards. So they're getting a ton of location and linkage points, and of course, being able to reduce transportation needs in that sense. So, but we're going to go ahead and wrap up here. Again, this has been our final session for the year. Thanks again to all of you for checking out this session. Thanks to our sponsors, Anderson Window, Panasonic. Thanks to some of our other members and volunteers and all of the presenters that we've had throughout the year. Make sure to check us out on January 4th. We'll be kicking the year off with EPA WaterSense certification program. So we're going to be signing off now.